Alright, welcome to the video tutorial for pages 11 and 12 in your homework packets. Here we are doing it all mixed up. So the same rule holds. We calculate in Kelvin, which means anytime they give it to you in Celsius, you have to add 273 for it to be in Kelvin. And then you're going to be using one of these 5 equations. So right now I'm going to do you a favor and label them. When it only has pressure in it, that's Dalton's law. Okay, Pivnert is what we call the ideal gas law. All right, PV is Boyle's. Okay, Charles watches direct TV, so this is Charles' law. And that leaves pressure and temperature. That's Gay-Lussac's law. All right, so for each question, you need to say which law you're going to use, and then you need to give an answer with units. And the best way to do that is going to be boxing in your given numbers and circling your unknowns. You can identify your variables and choose which equation to use. So we're going to start this video off with number 4. On number 4, they're asking me for moles, which should be a dead giveaway, because only one of these equations up here has moles in it, and it's right there, the N. So already I can pretty much guess this is going to be the ideal gas law. But I'm going to keep looking and say moles is N. They give me a liters, which is volume. They give me a pressure of ATM, and they give me a temperature, kind of. And I'm going to cross that out because I know that I cannot calculate in Celsius. So in order to make this a number that I can work with, I have to convert Celsius 75.0, to Kelvin by adding 273. Okay, and that gives me the temperature of 348. Alright, so I'm looking for N. They give me PVT, and the other one I'm missing will be that R. And R is on the back of the periodic table. R is the ideal gas constant, so it's never in the equation, because only the variables are. So you need to remember to put 0.0821 for that. Okay, 0.821. So now I have all my givens and my unknown. Now last time, on the last video, if you watched it, let me write down the ideal gas law here first. Okay, on the last video, if you watched it, I recommended doing your algebra before you add in any numbers. So our equation for the ideal gas law, almost there. PV equals nRT. And I use a different color for that. N is what I'm looking for. I'm solving for an N, number of moles. So the algebra I need to do is have N times R times T. And I want N alone. So the opposite of times RT would be divide by RT. And that would get me N all by itself on the right side of the equation. But that means I also have to divide the left side of the equation by RT. So that leaves me with N equals P times V over R times T. And now that I have my equation, I did the algebra, I just plug in the numbers. Okay, so that's going to be pressure 0.85 times volume 15.5 divided by R 0.0821 times temperature 348. So I just plug that into my calculator. Alright, the top is 0.85 times 15.5. I'm going to hit divided by, and I'm going to use my parentheses, otherwise it won't work with order of operations. So divided by 0.0821 times 348, and close the parentheses. Gives me an answer of 0.46. Okay, so 0.46, and it says to include units. The unit for mole is just mole, like that. Alright, then we're going to move down. Let's take a look at number 6 together. Alright, we're going to box and circle and try and decide which equation we're using. A tank contains a mixture of the following 3 gases. So they're giving me this, this, and they are asking me for total pressure. So they tell me mmHg, which is a pressure. They tell me ATM, which is a pressure. They tell me mmHg, which is a pressure, and they're asking me for total pressure, PT. So I'm going to look up and find an equation that only has pressure in it, and that would be this one, Dalton's law. So I'm going to go ahead and write that down, Dalton's. That's the law I'm going to be using for this. Alright, so we can plug that in. I am solving for PT. Okay, they're asking me for total pressure, just like they did up here. The total pressure is the first plus the second plus the third gases. So I can say equals 445 mmHg plus 1.25 atm plus 515 mmHg. Now this is from day 1 homework, and we have a problem right here. And that problem is I can't add these numbers together because atm is a different unit, and I can only combine like terms. They all have to be in the same unit. They tell me that they want the answer in mmHg, so that means I need to get this number in millimeters of mercury as well. So I'm going to do that conversion down here. Okay, I'm going to say 1.25 atmospheres. If I convert that into millimeters of mercury, so I just go down to atmospheres, and I turn it into mmHg. In order for the top to equal the bottom, I would say 760 mmHg equals 1 atmosphere, like this. 760 on top and 1 on bottom this time. So that means I need to multiply and then divide by 1. So I can look here and say 1.25 times 760 divided by 1, 950. So now I can come in and say I don't want this number. Okay, I want this to be 950 mmHg. And now that I have all 3 of my partial pressures in millimeters of mercury, I can just add them together. So I'm going to do that. And let's see if I can get it where there's no glare. 445 plus 950 plus 515 gives me a total pressure of 1,910. And they asked me for that unit, so I can do that. 1,910 mmHg, like that. Okay, so that's 2 of the types of problems. Let's go ahead and flip over to page 12. It's more mixed practice, just like it was on this, so the same rules apply. Okay, and we're going to look at number 7. A scientist's 50 liters, there's a given, and liters is a volume. Gas canister with air pressure of, okay, they're giving me a pressure, is exposed to cold lake water, which causes the volume to change, okay, which means this is a second volume, and they're asking me for new pressure. So they're asking me for a second pressure, which makes this one the first volume and pressure. Okay, so I've got 2 pressures and 2 volumes. If I look back here, the equation with 2 pressures and 2 volumes is this one, P1V1 equals P2V2, and that will be Mr. Boyle's law, B-O-Y-L-E-S. And remember, I taught my students at least that Boyle's has pressure and volume hiding in his name. That's how I know PV is his. Okay, so I'm going to write down my equation. Alright, P1V1 equals P2V2. And I'm going to go ahead and do it like this. I'm going to do my algebra before I plug in numbers, which means rearrange. That's what algebra is, rearranging the equation. So instead of P2 times V2, to get rid of times V2, I divide by V2. Okay, and that cancels out. I'm multiplying and dividing by the same thing. So I'll get P2 alone equals P1 times V1. I also have to divide that side by it. So my new equation is my answer, my second pressure, my new pressure equals my first pressure times my first volume divided by the second volume. And really, if we look at this too, my volume is getting smaller. Okay, so if volume goes smaller, and Boyle's law is an inverse relationship, that means my pressure should be bigger. So in order for this answer to be correct, it should be bigger than 786. And I'm going to make myself little notes. This answer better be bigger than 786 if I did it right. Okay, let's plug those numbers in then. P1 we said is 786 times V1, 50.0. And that answer divided by the second volume, 47.0. Okay, I can just plug that in now. 786 times 50 equals divided by 47.0. All right, 836, and sure enough, that's bigger than that answer. That looks great. 836.1 or 0.2, I'll just say 0.17, just to keep life interesting. And whatever unit I use for my first pressure, that's the answer for my second pressure, so that would be mmHg. Okay? I think you'll find that rearranging your equation before you plug in the numbers will make it a little bit easier. Let's look at number 9. If an oxygen tank is warmed in the sun and pressure goes from, okay, so here's a pressure at this temperature. I'm going to box it in, but I'm also going to cross it out, okay, because I know I cannot calculate in Celsius. We calculate Kelvin, so this is kind of the first temperature, okay, and pressure goes to this. Okay, I have a second pressure. They're asking me for a new temperature. So they're asking me for T2, and I'm going to write that in red. I like doing that. I like having the colors. It helps my eyes. Alright, so I need an equation with 2 pressures and 2 temperatures. I'll look back here, and this is going to be my equation. And I should know that that's Gay-Lussac's law. So I'm going to write that here. Gay-Lussac. Okay. And that equation, again, is P1 over T1. Oops, darn it, I'm using the wrong colors. I'm going to cross that out. P1 over T1 divided by P... Ugh. Wow, I'm really struggling, guys. I'm just going to white all of this out. I'm trying to go too fast. I can't talk and think at the same time, apparently. Alright. Why don't I just do this and copy it? Keep messing up. P1 over T1 equals P2 over T2. Jeez, that's what we're looking for. Okay, I'm going to do the algebra before I plug in any numbers to try and see if I can simplify. I mean, we have the fraction problem, so either Gay-Lussac's or Charles, or if we were doing Avogadro's equations, we cross-multiply those. So I'm going to end up with P1 times this top one times that bottom one, which is T2, equals this top one, P2, times that bottom one, T1. And I'm still not done. I have to do some more algebra because my T2, my red one, is still not alone. So instead of T2 times P1, I need to unmultiply, which means divide. If I multiply and divide both of those, then I get T2 alone. But I have to do it over here too. So there is my equation. And I can plug in numbers. So my second pressure, be really careful there, that's why I write it in. I'm going to say 515 times my first temperature, but I don't have that yet. I have my first, oh darn it, knocking stuff off my desk. I have my first temperature in Celsius, but I need it in Kelvin. So I have to add 273, plus 273. Okay, so there's the temperature I'm allowed to use, 294. Alright, and if I hadn't crossed that out, after I did all this algebra work, I might forget and just plug in 21, and that's going to be a disaster. So that's why I crossed it out right away. Alright, so that's P2 times T1. Now I need to go divided by P1, which is right there. 425. Okay, now we just hit enter. 515 times 294. Whoops, that's not it. 515 times 294. Okay, now divided by 425. That should get me, let me just double check my math here, an oxygen tank. Good deal. 356. Okay. 356.2, and that's the temperature, so that's Kelvin. Now let's double check to make sure this looks right. Okay, my pressure is increasing from P1 to P2. And it's a direct relationship, so my temperature should be increasing from 294 to 356. That looks good. Alright, so that answer makes sense. Let's go down here. Number 11. What's the volume in liters? That's what they're asking me for. I'm solving for volume of a balloon if it contains, alright, they're telling me moles, which should be a dead giveaway. I only have one equation that has moles in it, this unit. And that's this one, the word mole. So that's going to be a Pivnert, which makes this the ideal gas law again. It's EAL. And they give me a temperature of, whoops, I'm going to cross that out, because they didn't put it in Kelvin. And standard pressure. Standard pressure is 1 atm. And that is on the back of my periodic table. Standard temperature and pressure, 1 atm, right there. Okay, so they gave me pressure. Remember, R is also on the back of your periodic table, 0.0821. So they gave me everything I need except for my temperatures in the wrong unit. 24 plus 273. Now I'm in Kelvin, equals 297. So now I've got it. I'm going to write my equation out. That's going to be pressure times volume, like this, equals nRT. So to get my variable, what I want, volume all by itself, if I'm multiplying by P, I have to divide by P on both sides. So V equals nRT divided by P. And now I can plug in. I know that my N is 2.63. My R is always 0.0821. My temperature in Kelvin is 297, divided by pressure, which luckily is just 1. Can calculate that out. 2.63 times 0.0821 times 297, enter, divided by 1, doesn't change anything. 64.1. And then we have to ask, what is it? It says volume in liters. L, like that. Alright, that's what we're doing. If you need more help, please, please, please come in and get some help, because you've got to get practice at knowing which law or which equation to use. Thanks, guys.